Hello everybody, my name is Jeremy and I'm going to be showing you how to get started on the malloc lab number 5 for this class. So I have my terminal and my lab 5 tar already, so I'm going to untar that. And it's going to produce a bunch of files, and we'll get into the lab 5 directory that it made. And so you see we have a bunch of files, and the only ones that you need to really worry about are mm.c and the README in case you're looking for information about the lab itself. So if you look at the README, it will show you just some information about the files and how to do stuff. So you always want to look at your READMEs, of course. So let's look at mm.c. I'll open that in Emacs because we're going to be editing it in the course of this lab. And that'll open up. So we've got our source file, mm.c, open in Emacs here. And so this is the starter code. You're going to have to go in and fill in some functions to make it actually do what it's supposed to do. So we're going to be implementing the memory allocator malloc. And the general overview of that is that you have, as we've talked about, you have your heap in memory, and malloc is the program that allocates and deallocates space on the heap as the program's requested. So there's two methods in malloc that we're going to be implementing. Malloc right here, and and free right here. Yeah, so what malloc is going to do is allocate a block on the heap of a certain size, whatever size the user specifies, and then it's going to return a pointer to that memory. And then when the user's done with that, they'll call free on that same pointer, and the malloc system will put it back into the pool of free memory that can be allocated. So the two functions that you're going to be implementing in this lab are malloc and free. And malloc is kind of the more simple one. We give you some code to start with, and it's going to basically just take a block of the size and return a pointer to it. And that's not too hard for the purposes of this lab. The harder part is for free to take the pointer to the memory that the user is done using and put it back into the pool of allocatable memory on the heap. And to keep track of all of those different blocks of memory, we're going to be using a doubly linked list. As you can see in the source files at the top, there's a kind of an ASCII picture of that here. And it summarizes the structure, and the structure definition is just below. So we're going to have this doubly linked list. So you have, like a linked list, you have a element and a pointer to the next thing. But with a doubly linked list, you just have two pointers, one to the next thing, one to the previous thing. So that makes it really easy to traverse the list back and forth when you're looking for the thing of whatever appropriate size. And with that, there's going to be, mostly in the free method, a lot of management that you're going to have to do to keep the linked list, the doubly linked list of the free blocks consistent and helpful, because you're going to have to smash blocks together if they're right next to each other, or split them if they're too big. So that's what free is going to do. And all this is going to have a lot to do with manipulating pointers. There's a lot of code in the source file that is already provided. So you have functions for coalescing free blocks, removing free blocks, inserting free blocks into the list, and searching the list for a block of a certain size. And you're going to be using all of those to implement malloc and free. So once you're done writing your malloc implementation and you want to test it, we provide the mdriver program, the source files in mdriver.c that you can use to test your malloc implementation. And you're going to make that with the make, and it's going to produce this mdriver program. To test your malloc implementation, you just run mdriver. And of course, my malloc implementation doesn't exist because I just untarred it just now. So of course, it fails every test. The mdriver program also has some options that you can use to generate more detailed information, and you can find those by using the H flag. So that's a general overview of how you're going to implement and test your malloc. Pointers are kind of hard, so you may get frustrated in this lab, but don't worry about it. It's a challenging lab, so good luck and have fun.